Now for these questions, we need to multiply whole numbers by 10. And we can do that just by writing a 0 on the end of the number. So 28 times 10 is 280. That's because 28 times 1 is 28. And if there's a 0, an end 0 in a multiplication question, there will be an end 0 in the answer. So now we have 509 times 10. That's 5090 because we can just write a 0 on the end of our number to multiply it by 10. And now we have 86,054 times 10. That's 860,540. So the number we started with a 0 on the end. Now putting a 0 on the end is a good way to multiply whole numbers by 10, but to multiply decimals by 10 we need to use a different method. So be aware that this trick only works for whole numbers. And the reason why we can put a 0 on the end is because what's really happening when we multiply by 10 is that digits are moving one place value to the left, because when we have 10 of something, we have 1 of the next place value column along. So for this first question, we started with 28. To multiply by 10, we can move the digits one square across, or one place value across, but now we have an empty ones column, and to make it clear that the 2 is now in our hundreds, and the 8 now in our tens, we need to write a 0 in our ones to give us our answer 280. Then we started with 509, and when we multiply by 10, the digits move one place value to the left. We need to write a 0 in our empty ones column, so all of the other digits are in the correct place value column, and our answer is 5090. Then we had 86,054. If we move the digits one square to the left, we need to write a 0 in our empty ones column to give us our answer. Now for these questions, we need to multiply whole numbers by 100. And we can do that just by putting 2 zeros on the end. First, we have 63 times 100. That's 6,300. So 63, the number we started with 2 zeros on the end. And we can do that because 63 times 1 is of course 63. But then, if we have 2 end zeros in a multiplication, we need 2 end zeros in our answer. Now, what is 700 times 100? That's 70,000, so 700 with 2 zeros on the end. And that's because 700 times 1 is 700, so 700 times 100 is 70,000. You could also count that in this multiplication we have 1, 2, 3, 4 end zeros, and 7 times 1 is 7, so because we have 4 end zeros in our question, we need 1, 2, 3, 4 end zeros in our answer. So now we have 5008 times 100. That's 500,800. So 5008 with 2 zeros on the end. And we can do that because 5008 times 1 is 5008. And if we have 2 end zeros in the question, we have 2 end zeros in the answer. Now it's really important to understand that putting 2 zeros on the end is an effective way to multiply whole numbers by 100, but it doesn't work for decimals. If we have decimals, we need to use a different method. But to see why it works, let's think back to this first question. We had 63 and we needed to multiply by 100. But remember, multiplying by 100 is the same as multiplying by 10 and then by 10 again. And we know that when we multiply by 10, digits move one place to the left. So if we're multiplying by 100, that's like multiplying by 10 twice, and that's why the digits move 2 places to the left. But to make it clear that the 6 is now in our thousands and the 3 in our hundreds, we need to write zeros in our empty place value columns for our tens and ones. Then we had 700 times 100. Again, multiplying by 100 means moving the digits 2 place values to the left. We can write zeros in our empty tens and ones column to give us our answer. And then we started with 5008. Multiplying by 100 is like multiplying by 10 and then by 10 again, so that's why the digits move 2 squares to the left. We write zeros in our empty place value columns to give us our answer 500,800. Now we need to multiply whole numbers by 1,000. And we can do that by writing 3 zeros on the end of our number. So notice there's 3 zeros in 1,000, so we write 3 zeros on the end of our number. So 6 times 1,000 is 6,000, because 6 times 1 is 6, but then if we have 3 end zeros in a multiplication question, we need 3 end zeros in our answer. Now we have 78 times 1,000. That's 78,000, so 78 with 3 zeros on the end. 78 times 1 is 78, but multiplying by 1,000 means we need to write these 3 zeros on the end of our answer. And finally, we have 201 times 1,000. That's 201,000. 201 times 1 is 201, so 201 times 1,000 is 201,000. Now it's important again to understand that multiplying by 1,000 we can write 3 zeros on the end only if the numbers that we're multiplying are whole numbers rather than decimals. If we have decimals, we're going to need to use a different method. But to see why this works, let's think back to 6 times 1,000. So we started with 6, and multiplying by 1,000 is like multiplying by 10, and then by 10 again, and then by 10 for a third time, because 10 times 10 times 10 is 1,000. And that's why, to multiply by 1,000, we can move the digit or digits 3 squares or 3 place values to the left. So now the 6 has moved to our thousands column, so we need zeros in our hundreds, tens and ones to make it clear that the 6 stands for 6,000s. Then we had 78 times 1,000, and if we move the digits 3 place values to the left, write zeros in our empty hundreds, tens and ones columns, that gives us our answer 78,000. And finally, we had 201. If we move the digits 3 squares to the left, then we've multiplied by 1,000. But to show the place values that these digits are now in, we need to write zeros in our empty squares to give us our answer 201,000. Now we need to solve missing number problems for multiplying by 10, 100 or 1,000. And for these questions, we know that the missing number must be 10, 100 or 1,000, because if we look at the number in our answer, we have the number in our question, but with zeros on the end. So here we have 30 with 3 zeros on the end, here we have 78 with 2 zeros on the end, and here we have 2050 with 1 zero on the end. So 30 times what equals 30,000? Our missing number is 1,000. That's because 30 times 1 is 30, but then multiplying by 1,000 we write 3 zeros on the end of our number. And what really happens when we multiply by 1,000 is that the digits move 3 place values to the left, and we write zeros in our empty hundreds, tens and ones columns. Now 78 times what is 7,800? Our missing number is 100, because our answer is 78 with 2 zeros on the end, and we have 2 zeros in 100. And what's really happened when we multiply by 100 is that the digits have moved 2 squares to the left, and we have zeros in our empty tens and ones columns. Now 2050 times what equals 20,500? Here our missing number is 10, because if we look at our answer, we have the number in our question but with an extra 0 on the end. So we've multiplied by 10 because what's really happened is that the digits have moved 1 square to the left, and we've written a 0 in our empty ones column. Now for these questions, we need to multiply a single digit number by a multiple of 1,000. First, we have 3 times 2,000. That's 6,000, because 3 times 2 is 6, and then if we have 3 end zeros in a multiplication question, we need 3 end zeros in our answer. Now we have 6,000 times 5. That's 30,000, because 6 times 5 is 30, but after we've multiplied the non-zero digits, we need to count the zeros in the question. We have 3 end zeros in the question, so we need to write 3 end zeros in our answer after the 30. Now it might look like this 0 here is an end 0, but remember, we got this 0 here because 6 times 5 is 30. If there's 3 end zeros in the question, we need to write 3 end zeros after we've multiplied the non-zero digits. So now, what is 7 times 7,000? That's 49,000, because 7 times 7 is 49, and if we have 3 end zeros in the question, we need 3 end zeros in the answer. Now to think about why this method works, remember 2,000 is the same as 2 times 1,000. So first we can multiply by 2, and 3 times 2 is 6, and then we can multiply by 1,000. And on a place value chart, to multiply by 1,000, we can move the digit 3 squares to the left, because multiplying by 1,000 is like multiplying by 10, and then by 10 again, and then by 10 for a third time. So now this 6 is in our thousands column, so we need to write zeros in our hundreds, tens and ones to make our place value clear. Then we had 6,000 times 5. We could do 6 times 5 to get 30, and then multiply by 1,000 to get 30,000, because 6,000 is the same as 6 times 1,000. So instead of 6,000 times 5, we can do 6 times 5 and then multiply by 1,000, and we do that by putting 3 zeros on the end. Then we had 7 times 7,000. 7 times 7 is 49, and then we could multiply by 1,000, and that meant we could put 3 zeros on the end, because we can put 3 zeros in our empty hundreds, tens and ones columns. Now we need to multiply by a 4-digit number using the grid method. We have 5 times 5,289. What we need to do is partition our 4-digit number. So this 5 stands for 5,000, this 2 for 200, this 8 for 80, and this 9 for 9. So now we can write the numbers onto our grid. We can write our single-digit number on the left and our partitioned number on top. Now, for this box here, we need to work out 5,000 times 5. That's 25,000, because 5 times 5 is 25, and then we need 3 end zeros. Here, we need to work out 200 times 5. That's 1,000, because 2 times 5 is 10, and then we need 2 end zeros. Here, we need to work out 80 times 5. That's 400, because 8 times 5 is 40, and then we need one end zero. And here we need to work out 9 times 5, which is 45. So now that we've filled out our grid, all we need to do is add up the numbers that are on the grid. And when we do that, we get our answer 26,445. Now let's try 3 times 7,441. We need to partition our 4-digit number. So that's 7,440 and 1. So now we can write the single-digit number on the left and the number that we've partitioned, or the partitioned number, on top. Now here we need 7,000 times 3. That's 21,000, because 7 times 3 is 21, and then we need 3 end zeros. Here we need 400 times 3. That's 1,200, because 4 times 3 is 12, and then we need 2 end zeros. Here we need 40 times 3, so that's 120. 4 times 3 is 12, and then we need 1 end zero. And here we need 1 times 3, so that's 3. Again, all we need to do now is add up the numbers that we've written on our grid. And when we do that, we get our answer, 22,323. If we go back to the first question we solved, we had 5,289. So there's 5 thousands, 2 hundreds, 8 tens, and 9 ones. We were multiplying by 5, so we can show what we have here 2, 3, 4, 5 times. And then, if we regroup 10 ones into 10, then 10 tens into 100, and 10 hundreds into 1,000, 10 thousands into 1 10,000, you can see that we now have 2 10,000s, 6 thousands, 4 hundreds, 4 tens, and 5 ones. Then we had 7,441, so there's 7 thousands, 4 hundreds, 4 tens, and 1 one. We were multiplying by 3, so we can show this 2 3 times, and then when we do our regrouping, you can see that we end up with 2 10,000s, 2 thousands, 3 hundreds, 2 tens, and 3 ones. Now we need to multiply using short multiplication. So first we have 3,084 times 3. So we can set the question out like this, with our larger number, so the number with the most digits on top. Now we start by multiplying our ones digit. 4 times 3 is 12, but that's a 2-digit number, and we can only have 1 digit in each place value column. So we need to write 12 as 1, 2, so with the first digit of the number above the next place value column along. And that makes sense, because in the number 12 we have 1 10 and 2 ones, so only the 2 ones goes in the ones column of our answer. So now we can move on to the next digit, so our tens digit. 8 times 3 is 24, but now we need to add the 1 10 that's on top. So 8 times 3 is 24, plus 1 is 25. Again, we can only have 1 digit in each square, so we need to write 25 as 2 5. Now 0 times 3 is 0, but we need to add the 200s on top, so we can write 2 in our answer line because that's a single digit number. So finally we have 3 times 3, and we don't have anything on top to add, and 3 times 3 is 9. So our answer is 9,252. Now we have 3,516 times 5, so we can set the question out in the same way and start by multiplying our ones digit. 6 times 5 is 30, so we need to write that 3 0. Now onto our next digit, so onto our tens. 1 times 5 is 5, but we need to add the 3 that's on top. So 1 times 5 is 5, plus 3 is 8. Now, 5 times 5 is 25, and we don't have anything on top to add, so we can write 25 as 2, 5, so with the first digit above the next place value column along. And now, 3 times 5 is 15, plus 2 is 17, so our answer is 17,580. Notice, once we got to the end, so when we did 3 times 5 is 15, plus 2 is 17, we could write both digits in our answer line, and that's because we didn't have any more digits to multiply. So now we have 9 times 1,515. Now it doesn't matter that the single digit number is written first, we still write the question out in the same way that we've been doing, so with the larger number, the number with the most digits on top. And we can do that because with multiplication, order doesn't matter. So now 5 times 9 is 45, so 4, 5. 1 times 9 is 9, but we need to add the 4 that's on top, and 9 plus 4 is 13. We need to write 13 as 1, 3, so with the first digit above the next place value column along. 5 times 9 is 45, but we need to add the 1 that's on top, so that gives us 46, so 4, 6. And now 1 times 9 is 9, and 9 plus the 4 that's on top is 13. We don't have any more digits to multiply, so we can just write the 13 in our answer. So that's 13,635. But now, let's look back to this first question. We had 3,084, so that's 3 thousands, no hundreds, 8 tens, and 4 ones. We can multiply by 3, so we can show the place value counters that we have here 3 times. Now we have 12 ones, but we can regroup 10 of those ones into 110. And that's why we write the 110 above the next place value column along, so above our tens. But now we have 25 tens. We can make 2 hundreds and 5 tens left over, and that's why we write the 2 above our hundreds column and the 5 in our tens answer line, because we now have just 5 tens. So our answer is 9,252, so that's 9 thousands, 2 hundreds, 5 tens, and 2 ones. Then we had 3,516, so that's 3 thousands, 5 hundreds, 1 10, and 6 ones. We were multiplying by 5, so we can show what we have 2, 3, 4, 5 times. But now we need to do some regrouping. We have 30 ones, but we can regroup those ones into 3 tens. And that's why we write 3 above our tens column and 0 in our ones answer line, because we don't have any ones now that we've regrouped. But now we can regroup some of our hundreds into thousands. So instead of having 25 hundreds, we have 2 thousands and 5 hundreds. And we can regroup 10 of these thousands into 1 10,000. So now we have 1 10,000, 7 thousands, 5 hundreds, and 8 tens, and 0 ones. So that's why our answer is 17,580. Finally, we had 9 times 1,515. So we can show 1,000, 500s, 110, and 5 ones. And because we're multiplying by 9, we can show that 2, 3, 4, 5, 6, 7, 8, 9 times. So now we have 45 ones, but we can regroup these into 4 tens and 5 ones, and that's why we write 4 above our tens column and 5 in our ones answer line. But now we have 13 tens, and we can regroup those into 100 and 3 tenths, and that's why we write 1 above our hundreds and 3 in our tens answer line. But now we have 46 hundreds. We can regroup those into 4 thousands and 6 hundreds. So that's why we write 4 above our thousands and 6 as the hundreds digit of our answer. But now we have 13 thousands, and we can regroup 10 of those into 1 10,000. So now you can see that we have 1 10,000, 3 thousands, 6 hundreds, 3 tens, and 5 ones. Now we need to multiply 2 multiples of 10, and we can use mental methods for this. So first we have 70 times 60. We know that 7 times 6 is 42. So 70 times 60 is 4,200. That's because after we've done 7 times 6, we need to count the zeros in the question, because if there are 2 zeros in a multiplication question, there will be 2 zeros in the answer. So that's 4,200. Now we have 50 times 80. We know that 5 times 8 is 40, and that means that 50 times 80 is 4,000. After we've done 5 times 8 and written 40, again we need to spot that there are 2 zeros in the question. So after we've written our answer to 5 times 8, we need to write 2 zeros. Now it's important to understand that this zero here isn't an end zero. We got this zero by multiplying the non-zero digits in the question. So multiplying 5 times 8 to get 40, and then we counted that we need 2 zeros after that. So our answer is 4,000. Now let's try 90 times 90. We know that 9 times 9 is 81. So that means that 90 times 90 is 8,100. After we've done 9 times 9, we need to count the zeros in the question, because if we have 2 end zeros in a multiplication question, we need 2 end zeros in our answer. So that's 8,100. Now let's think about why this method works. Why you can just multiply the non-zero digits and then count the zeros. We know that 70 is the same as 7 times 10, and we're multiplying by 60, which is the same as 6 times 10. But remember, with multiplication, we can multiply in any order. So we can start with 7 times 6. That's 42. Then, to multiply by 10, we know that the digits move 1 square to the left, and we can write a 0 in our empty ones column. But then we need to multiply by 10 again. So again, we can move the digits 1 square to the left, and again write a 0 in our empty ones column. So that's why our answer is 4,200. Then we had 50, which is 5 times 10, and we were multiplying by 80, which is 8 times 10. Again, we can multiply in any order. So if we start with 5 times 8, we get 40. Then we can multiply by 10, so move the digits 1 square to the left with a 0 in our empty ones column. But then we need to multiply by this 10 here as well. So again, we need to move the digits 1 square to the left and write a 0 in our empty ones column. So that's why our answer is 4,000. 5 times 8 is 40, but then we needed to twice move the digits to the left and write a 0, and that's why we have 2 zeros after the 40. Then we had 90, so 9 times 10, and we were multiplying by 90, so 9 times 10. We can start by doing 9 times 9, that's 81, and then to multiply by 10, we move the digits 1 square to the left, and we need to multiply by 10 again, so move the digits 1 square to the left again, and that gives us our answer. Now we need to multiply two two-digit numbers using the grid method. First, we have 66 times 53. The first thing to do is to partition both numbers into tens and ones. So with 66, we have 60 and 6, and with 53, we have 50 and 3. So now we can write our partitioned numbers down the side and top of the grid. It doesn't really matter which way round we write the numbers, but let's write 60 and 6 on the left and 50 and 3 on top. So now we need to fill in our grid. For this box here, we need to work out 60 times 50. That's 3,000 because 6 times 5 is 30, but after we've written the 30, because there are two end zeros in the question, we need two end zeros in the answer after we've multiplied 6 by 5 to get 30. So we need 3,000 in this box here. For this box, we need to work out 60 times 3. That's 180 because 6 times 3 is 18, and then we need one end zero. For this box here, we need 6 times 50, so that's 300 because 6 times 5 is 30, and then if there's one end zero in a multiplication question, there will be one end zero in the answer. And this box here, we need 6 times 3, so that's 18. So now we just need to add the numbers that we'd written in the boxes, and when we do that, we get our answer 3,498. So now let's try 73 times 45. With 73 we have 70 and 3, and with 45 we have 40 and 5. So let's write our partitioned numbers on the grid. We have 70 and 3, and then we have 40 and 5. So for this box here, we need to work out 70 times 40. That's 2,800 because 7 times 4 is 28, and then if we have two end zeros in the question, there will be two end zeros in the answer. For this box, we need 70 times 5. That's 350 because 7 times 5 is 35, and then we need one end zero. Here we need 3 times 40, so that's 120 because 3 times 4 is 12, and again we need one end zero. And here we have 3 times 5, which is 15. So now we just add up the numbers that are on the grid, and when we do that, we get our answer 3,285. Now we're going to multiply two two-digit numbers using long multiplication. With this method, we're going to get two answer lines. So for this first question, on our first answer line, we're going to multiply 71 by 6. Then, on our second answer line, we're going to multiply 71 by the 4 that's in our tens, so by 40, and then we're going to add up our answer lines. So first, 1 times 6 is 6, and then 7 times 6 is 42. We don't have any more digits to the left, so we can just write the 42 in our answer line. So now we've multiplied 71 by 6. So we're going to multiply 71 by the 4 digit. But because the 4 is a tens digit, we need to write a 0 in our ones. So a 0 on the end of our second answer line. Now 1 times 4 is 4, and 7 times 4 is 28. We don't have any more digits to the left, so again we can just write the 28 in our answer line. Now the last thing we need to do is add up our answer lines. 6 plus 0 is 6, 2 plus 4 is 6, 4 plus 8 is 12, so 1, 2, and 1 plus 2 is 3. So our answer to 71 times 46 is 3,266. Now we have 81 times 37. we start by multiplying our ones digits, and 1 times 7 is 7. So now we need to multiply 8 by 7. That's 56, and we don't have any more digits to the left, so we can just write 56 in our answer line. So now we've multiplied by this 7, so you could cross out the 7, because now we're not going to multiply anything by 7, we're going to multiply 81 by the 3 that's in our tens. But because this 3 is in our tens, we need to write a 0 in our ones. Now 1 times 3 is 3, and 8 times 3 is 24, which we can write in our answer line because we don't have anything else to multiply. So now we add up our answer lines. 7 plus 0 is 7, 6 plus 3 is 9, 5 plus 4 is 9, and nothing plus 2 is 2. So our answer is 2,997. Now we have 54 times 3. So we start by multiplying the digits in our ones. 4 times 3 is 12, but 12 is a 2-digit number. So just as with short multiplication, we need to write the first digit on top of the next place value column along. So 4 times 3 is 12, and we write that 1, 2. So now we have 5 times 3. That's 15, but we need to add the 1 that's on top. So 5 times 3 is 15, plus 1 is 16. Now we can cross out our working, and this is important because we need to remember when we're multiplying by the 2 digit that we've already added this 1 up here. We also need to remember to write a 0 as the last digit of our second answer line, because this 2 is in our tens. So really, we're not multiplying by 2, we're multiplying by 20. But we'll get the same answer if we just write a 0 at the end of our answer. So now 4 times 2 is 8, so we can just write 8 in our answer line. And now 5 times 2 is 10. We don't have any more digits to multiply, so we can write 10 in our answer line. Now 2 plus 0 is 2, 6 plus 8 is 14, so 1, 4, 1 plus 1 plus 0 is 2, and nothing plus 1 is 1. So the answer to 54 times 23 is 1,242. Now for our last question, we have 53 times 56. We start by multiplying 3 by 6. That's 18, so 1, 8, with the first digit above the next place value column along. So now 5 times 6 is 30, but we need to add the 1 that's on top, and 30 plus 1 is 31. We don't have any digits to the left, so we can write the 31 in our answer line. Now we need to remember to cross out our working because we're going to multiply by the 5 digit that's in our tens. So again, we need to remember a 0 on the end of our second answer line. 3 times 5 is 15, so 1, 5. And then 5 times 5 is 25, plus 1 is 26. We don't have any more digits, so we can write 26 in our answer line. So now 8 plus 0 is 8, 1 plus 5 is 6, 3 plus 6 is 9, and nothing plus 2 is 2. So we get 2,968. Here we need to multiply a multiple of 100, so a number that ends in 2 zeros, by a multiple of 10, so a number that ends in 1 0. First, we have 700 times 60. What we can do is multiply the non-zero digits first, and we know that 7 times 6 is 42. That means that 700 times 60 is 42,000, because after we've worked out that 7 times 6 is 42, we need to count the end zeros in our multiplication question. We have 3 end zeros in the question, 2 here and 1 here, and that means that we need 3 end zeros in our answer. So 700 times 60 is 42,000. So now we have 500 times 80. So first, 5 times 8 is 40. And that means that we can work out 500 times 80. We get 40,000 because 5 times 8 is 40. But then, after we've written the 40, so after we've multiplied the digits in our question which are not 0, we need to count our end zeros. Again, we have a total of 3 end zeros in the question, so we need 3 end zeros in the answer. Now it might look like this 0 here is an end zero, but we can't count that because we got this 0 by multiplying the non-zero digits in the question, so multiplying 5 by 8. Now we have 900 times 90. 9 times 9 is 81, so 900 times 90 is 81,000, because after we've written the 81, because there are 3 end zeros in the question, we need 3 end zeros in the answer. So that's 81,000. And to see why this method works, remember 700 is 7 times 100, and we're multiplying by 60, and that's 6 times 10. With multiplication, we can multiply in any order. So we can do 7 times 6 first to get 42. Then we can multiply by 100, and remember we can do that by putting 2 zeros on the end or moving the digits 2 place values to the left. And finally we need to multiply by this 10, and we can do that by putting another 0 on the end by moving the digits 1 square to the left. And that gives us our answer, 42,000. Then we had 500, so that's 5 times 100, and we were multiplying by 80, so that's 8 times 10. We multiply the non-zero digits first, and 5 times 8 is 40. Then, if we multiply by 100, we're putting 2 zeros on the end, because the digits move 2 squares to the left. And then, if we multiply by 10, we're putting another 0 on the end, because multiplying by 10 moves the digits 1 square to the left, or 1 place value to the left. So that gives us 40,000 as our answer. 900 is 9 times 100, and 90 is 9 times 10. 9 times 9 is 81. To multiply by 100, we can put 2 zeros on the end, and then to multiply by 10, we can put another 0 on the end. So that's 3 zeros on the end altogether to give us our answer, 81,000. Now we're multiplying a 2-digit number by a 3-digit number using the grid method. So first we need to partition our numbers. 56 is 50 and 6. 234 is 230 and 4. So now we can write these partitioned numbers down the side and top of our grid. So we have 50 and 6 and 230 and 4. So now for this box here, we need to work out 50 times 200. That's 10,000 because 5 times 2 is 10. But then, if we have 3 end zeros in a multiplication question, we need 3 end zeros in our answer. Here, we need to work out 50 times 30. That's 1,500, because 5 times 3 is 15, and here we have 2 end zeros in our multiplication question altogether, so we need 2 end zeros in our answer. Here we have 50 times 4, that's 200, because 5 times 4 is 20, but then after the 20, after we've multiplied our non-zero digits, we need to put 1 end zero on the end. Here we have 6 times 200, which is 1,200, because 6 times 2 is 12, and then we need 2 end zeros. Here we have 6 times 30, so that's 180, because 6 times 3 is 18, and then we need 1 end zero. And finally, we have 6 times 4, which is 24. So now, to get our answer, we just need to add up the numbers that are on our grid. We can do that using column addition, and when we do that, we get our answer 13,104. Now we have 94, so that's 90 and 4, and we're multiplying by 517, so 510 and 7. We can write the partitioned numbers on our grid, and now for this box we need to work out 90 times 500. That's 45,000, because 9 times 5 is 45, but then we have 3 end zeros in the question, 1 here and 2 here, so we need 3 end zeros in our answer. For this box, we need 90 times 10. That's 900. You could think of this as being 9 times 1 with 2 end zeros, or 90 times 10 is 90 with a 0 on the end. Now we need 90 times 7, so that's 630, because 9 times 7 is 63, and we need 1 end zero. Here we need 4 times 500, that's 2,000, because 4 times 5 is 20, but then we need 2 end zeros after the 20, 2 end zeros after we've written our answer to 4 times 5. Here we have 4 times 10, so that's 40, and here 4 times 7, so that's 28. So now we just need to add up the numbers that are on our grid, and to do that we can use column addition. When we do that, we get our answer 48,598. So first we have 694 times 34. So on our first answer line, we're going to multiply 694 by 4. Then on our second answer line, we're going to multiply 694 by the 3 that's in our tens. And because it's in our tens, we're going to write a 0 as the ones digit of our second answer line. Then we're going to add up our answer lines to get our answer. So first, we start by multiplying the digits in our ones. 4 times 4 is 16, but that's a 2-digit number, so we need to write 16 as 16, so with the first digit above the next place value column along. Now we can move across and multiply 9 by 4. That's 36, but we need to remember to add the one that's on top, so 36 plus 1 is 37. Again, we have a 2-digit number, so we need to write that 37. Now we have 6 times 4, which is 24, but we need to add 3, and 24 plus 3 is 27. We don't have any more digits to the left, so although it's a 2-digit number, we can just write the 27 in our answer line. So now we've multiplied by the 4-digit, so we could cross this out if it makes it easier for us. What we do need to remember to cross out is our working above. We also need to remember that because this 3 is in our tens, we need a 0 in the ones digit, so at the end of our second answer line. Now 4 times 3 is 12, that's a 2-digit number, so we write 12 as 1, 2, so with the first digit above the next digit that we're going to multiply. 9 times 3 is 27, plus 1 is 28, so that's 2, 8, again with the first digit above the next digit that we're going to multiply. And now 6 times 3 is 18, plus 2 is 20. We don't have any more digits to multiply, so we can just write the 20 in our answer line. So now we need to add up our answers. 6 plus 0 is 6, 7 plus 2 is 9, 7 plus 8 is 15, so 1, 5, 1 plus 2 plus 0 is 3, and nothing plus 2 is 2. So our answer to 694 times 34 is 23,596. So now we have 785 times 23. 5 times 3 is 15, so that's 1, 5. 8 times 3 is 24, plus 1 is 25, so that's 2, 5. And now 7 times 3 is 21, plus 2 is 23, and we've got to the end, so we can just write 23 in our answer line. Now we need to remember to cross out our working and write a 0 at the end of our second answer line. 5 times 2 is 10, so 1, 0. 8 times 2 is 16, plus 1 is 17, so that's 1, 7, again with the first digit above the next digits that we're going to multiply. 7 times 2 is 14, plus 1 is 15, and we don't have anything else to multiply, so we can write the 15 in our answer line. 5 plus 0 is 5, 5 plus 0 is 5, 3 plus 7 is 10, so 1, 0, 1 plus 2 plus 5 is 8, and nothing plus 1 is 1. So our answer is 18,055. Now let's try 678 times 54. 8 times 4 is 32, so 3, 2. 7 times 4 is 28, plus 3 is 31, so 3, 1. 6 times 4 is 24, plus 3 is 27, and we don't have anything else to multiply on the left, so we can write the 27 in our answer line. Now we need to remember to cross out our working and write a 0 as the ones digit of our second answer line. 8 times 5 is 40, so that's 4, 0, with the 4 above the next digit that we're going to multiply. And it's important also to remember that we got this 0 here by multiplying 8 by 5. So we need to write this 0. We can't think that because it already has a 0 here that we just need to write the 4. We need to do 8 times 5, and if the answer ends in a 0, we need to write the 0 in our answer line. So now 7 times 5 is 35, plus 4 is 39, so 3, 9. 6 times 5 is 30, plus 3 is 33. So now we just add up our answer lines, and that gives us 36,612. Now we need to multiply a 4-digit number by a 2-digit number using long multiplication. So we start by multiplying our ones digits. 2 times 4 is 8. Now 6 times 4 is 24, but that's a 2-digit number, so we need to write 24 as 2, 4. 8 times 4 is 32, plus 2 is 34, so that's 3, 4. And now 3 times 4 is 12, plus 3 is 15. And we don't have any more digits to the left, so we can write the 15 in our answer line. So now we need to cross out our working and write a 0 in our second answer line, because now for our second answer line we're going to multiply by this 3, but this 3 is in our tens, so we need a 0 in our ones. 2 times 3 is 6. 6 times 3 is 18, so that's 1, 8, with the first digit above the next digits that we're going to multiply. 8 times 3 is 24, plus 1 is 25, so that's 2, 5. And now 3 times 3 is 9, plus 2 is 11. We don't have any more digits to the left, so we can write the 11 in our answer line. So now we just need to add up our answer lines to get our answer. 8 plus 0 is 8, 4 plus 6 is 10, so 1, 0. 1 plus 4 plus 8 is 13, so 1, 3. 1 plus 5 plus 5 is 11, so 1, 1. 1 plus 1 plus 1 is 3, and nothing plus 1 is 1. So our answer is 131,308. So now we have 4,781 times 23. 1 times 3 is 3. 8 times 3 is 24, so 2, 4. 7 times 3 is 21, plus 2 is 23, so that's 2, 3. And now 4 times 3 is 12, plus 2 is 14. We don't have any more digits to the left, so we can write 14 in our answer line. Now we can cross out our working and write a 0 as the last digit of our second answer line, because we're going to multiply by this 2 that's in our tens. What we could do here, if it's confusing, is to cross out the 3 as well, because we've already multiplied by 3 on our first answer line. But now 1 times 2 is 2, 8 times 2 is 16, so that's 1, 6, with the first digit above the next digit that we're going to multiply. 7 times 2 is 14, plus 1 is 15, so that's 1, 5. And now 4 times 2 is 8, plus 1 is 9. So we can add up our answer lines, and that gives us 109,963 as our answer. Now 5,967 times 61. 7 times 1 is 7, 6 times 1 is 6, 9 times 1 is 9, and 5 times 1 is 5. Now we need to remember to write our 0. We don't have any working to cross out, so now 7 times 6 is 42, so 4, 2. 6 times 6 is 36, plus 4 is 40, so that's 4, 0. 9 times 6 is 54, plus 4 is 58, so 5, 8. And finally, 5 times 6 is 30, plus 5 is 35. Again, we just need to add up our answer lines, and that gives us our answer, 363,987. Now here we have some missing digit long multiplication problems, and the way to solve these is to work through the problems in the same steps that we use for long multiplication. So we start by multiplying our ones digits, but we have 2 times something equals 4. Now you might think 2 times 2 is 4, so this answer box has to be a 2. But remember, with long multiplication, only the ones digit is written in the answer line, and if there's a tens digit, that's written above. So we could have multiplied 2 by something to get a ones digit of 4. So we could have done 2 times 7 is 14, and then carried the 1. So is this missing box 2 or 7? Well, what we can do is just try it out and then see if it works for the rest of the question. So for now, let's write a 2 in this box. 2 times 2 is 4, but then the next calculation we would do is 1 times 2, and 1 times 2 is not 8. So we know that this box isn't a 2, so that means it must be a 7. They must have done 2 times 7 to get 14, and then written the 1 above the next place value column along. Because now 1 times 7 is 7, and if we add the 1 on top, we get 8, so that fits with the rest of the question. Now 4 times 7 is 28, so that's 2, 8. And now for this box, we have something times 7 plus 2 is 58. So before they added the 2, they must have done something times 7 to get 56. We know that 8 times 7 is 56, because 56 divided by 7 is 8. So this box here must be an 8. 8 times 7 is 56, plus 2 is 58. So now we cross out our working, and there's a 0 as the last digit of our second answer line. Now 2 times 8 is 16, so that's 1, 6. 1 times 8 is 8, plus 1 is 9. 4 times 8 is 32, so that's 3, 2. 8 times 8 is 64, plus 3 is 67. So now 4 plus 0 is 4, 8 plus 6 is 14, so 1, 4. 1 plus 8 plus 9 is 18, so 1, 8. 1 plus 8 plus 2 is 11, so 1, 1. 1 plus 5 plus 7 is 13, so 1, 3. 1 plus 6 is 7. So we have a long multiplication that works. And notice we were following the same steps as if we were solving a long multiplication problem. And it's important because here, if we hadn't have done the addition, we wouldn't have written this one above, so we might have got this box here wrong. So now 8 times 2 is 16, so 1, 6. 1 times 2 is 2, plus 1 is 3. 5 times 2 is 10, so that's 1, 0. And now we have something times 2 plus 1 is 13. So before they added the 1, they must have done something times 2 to get 12, and we know that 6 times 2 is 12, so 6 must be our missing digit. 6 times 2 is 12, plus 1 is 13. Now we can cross out our working, and we know that the last digit of a second answer line is always a 0. But now we have 8 times something, and we have a 2 in our answer line. Now they might have done 8 times 4 to get 32, because that ends in a 2, and perhaps they carried the 3, or they might have done 8 times 9 to get 72, which also ends in a 2, and then they might have carried 7. Now to see what they did, let's just try something out. So if they did 8 times 4, they would have got 32, so that's 3, 2. Then the next calculation would be 1 times 4, but then adding the 3 on top would give 7, and that's what we have here. So we know that they must have done 8 times 4 to get 32, and then carried the 3. Now 5 times 4 is 20, so that's 2, 0. And now 6 times 4 is 24, plus 2 is 26. Now adding up our answer lines, 6 plus 0 is 6, 3 plus 2 is 5, 0 plus 7 is 7, and now to check that we've not made any mistakes, let's just keep going. 3 plus 0 is 3, 1 plus 6 is 7, and nothing plus 2 is 2. Now here we have 6 times something, and we have an 8 as the last digit of our answer. They might have done 6 times 3 to get 18 and then carried the 1, or they might have done 6 times 8 to get 48 and then carried the 4. So let's just try one of these out. If they did 6 times 3, that would have been 18, so 1, 8. But then the next calculation would have been to do 0 times 3, which is 0, and then add 1, which is 1. But we have a 4 in our answer line. So we know that they haven't done 6 times 3. Let's try 6 times 8. That's 48, so 4, 8. And then we would have 0 times 8 is 0, plus 4 is 4. We know that this digit must have been 6 times 8 to get 48, so must have been an 8. Now 1 times 8 is 8, and something times 8 is 56. Well, that's 7 times 8, because 56 divided by 8 is 7. So now we can cross out our working, and we know that at the end of our second answer line, we always have a 0. Now 6 times 5 is 30, so 3, 0. 0 times 5 is 0, plus 3 is 3. 1 times 5 is 5, and 7 times 5 is 35. So if we add up our answer lines, 8 plus 0 is 8, 4 plus 0 is 4, 8 plus 3 is 11, so 1, 1, 1 plus 6 plus 5 is 12, so 1, 2, 1 plus 5 plus 5 is 11, so 1, 1, and 1 plus 3 is 4. Now here, we need to multiply two multiples of 100, so that's two numbers that end in two zeros. First, we have 800 times 600, and we can use mental methods to solve this, because we know that 8 times 6 is 48, and that means that 800 times 600 must be 480,000. That's because after we've written our answer to 8 times 6, we can count the end zeros in our question. We have a total of 4 end zeros, 2 here and 2 here, and that means we need to write 4 end zeros in our answer. So that's 480,000. Now we have 500 times 900. We know that 5 times 9 is 45. So 500 times 900 is 450,000. That's because after we've done 5 times 9, we can count 4 end zeros in the question, so we know that we need 4 end zeros in our answer. Now for 700 times 700, we can work out that 7 times 7 is 49, and that will help us solve 700 times 700. We get 490,000 because again, after we've worked out 7 times 7, we just count the end zeros in our multiplication question and make sure that our answer has the same number of end zeros. So that's 490,000. Now to see why this method works, remember 800 is 8 times 100, and we're multiplying by 600, which is 6 times 100. But remember, with multiplication, order doesn't matter, so we can do 8 times 6 first to get 48. Then we know that when we multiply by 100, digits move 2 place values to the left, and then we can write 2 zeros on the end in our tens and ones column. But now we need to multiply by 100 again. So again, we move the digits 2 place values to the left and write 2 more zeros. So that's why our answer is 480,000, because 8 times 6 is 48, but then because we multiplied by 100 twice, we need 4 zeros on the end of 48. Now 500 is 5 times 100, and we're multiplying by 900, which is 9 times 100. Again, we can multiply in any order, and 5 times 9 is 45. When we multiply by 100, digits move 2 squares across, and we're multiplying by 100 again, so we need to move the digits another 2 place values across to give us our answer, 450,000. Now 700 is 7 times 100, and we're multiplying by 700, so by 7 times 100 again. 7 times 7 is 49. Multiplying by 100 means we put 2 zeros on the end of our number, but then multiplying by 100 again means we need another 2 zeros on the end of our number. And that's why our answer is 7 times 7, but then with 4 zeros on the end.